We're now going to solve problem 7 from chapter 10 in your book using the colleges and universities data. The first step is to normalize all the data. The reason why we normalize the data, the expenditures per student is much higher than all of the other data points, so the distances for expenditures would overshadow all of the other distances if we didn't normalize. So to normalize the data, the first thing that we're going to do is we're going to calculate the average and the standard deviation for each of our numerical data, the SAT, the acceptance rate, expenditures per student, top 10% high school, and graduation percentage. So on row 54, I'm going to type the word average, and in cell B55, I'm going to type standard deviation. To calculate the average of the median SAT, I'm just going to type equals average or mean. Open the parentheses, scroll up, and take the average of all of the SAT scores. I'm going to do exactly the same thing with the standard deviation. Equals STDEV, open up the parentheses, scroll up to make sure that I get the first school, and calculate the standard deviation of all of the median SATs. Now, because I used relative cell references, I can select the two cells and then use the fill handle to copy it out to all of the numerical columns. So now I've calculated the average or the mean and the standard deviation for each one of the numerical columns. The next step that I'm going to do is I'm going to copy this entire list, not including the average, the mean, and the standard deviation. So I'm going to hover over and copy, and I'm going to skip a column, and I'm going to paste this list in, starting in cell I3. So I'm just going to click in cell I3, and I'm going to click paste, and then I'm going to paste my column widths using the paste special, keep source column widths, which wasn't necessary, but it just makes it a little easier. Now what I'm going to do is I'm going to delete all of the numerical data, and with a good use of relative and absolute cell references, I'm going to be able to use one formula that will normalize each one of the numbers in this table. So what I've done is I've deleted all of the numbers in this table. Now what I'm going to do is for each data point, I'm going to take each data point. So for example, I'm going to take Amherst median SAT. I'm going to subtract it from the mean or the average of the SATs, the average or the mean of the SATs, and then divide by the standard deviation. So for Amherst, I'm going to put in the formula equals, open the parentheses, take Amherst median SAT, cell C4, then I'm going to subtract the average median SAT or the mean median SAT, but what I'm going to do with that cell reference is I'm going to use a mixture of a cell reference, and I'm going to change that cell reference using F4 until it says $54. So what I'm telling Excel to do is to take each data point and divide it by row 54 in that same column. Then I'm going to close my parentheses, I'm going to /, and then I'm going to click on the standard deviation for the median SAT, cell C55, and I'm going to do exactly the same thing. I'm going to hit my F4 until it says $55. So again, I'm instructing it in the same column to always divide by the standard deviation on row 55. Well, that's the only formula I need, and I can copy that down row K and then across the columns L, M, N, and N and O, or I can copy it across and then down. So what I'm going to do is I'm going to click back on cell K4. I'm going to use the fill handle to copy it down to column O, and then I can just simply double click the fill handle, and now I have normalized each one of the data points. Now the second step in the problem is to calculate the Euclidean distance. So we're told to calculate the Euclidean distance between Amherst, Caltech, and Duke. So I'm just going to concentrate on those three. I'm going to scroll to the right, and what I'm going to do now is I'm going to click any cell within the list, and I'm going to click Data and Filter. So I'm going to filter my normalized list. I'm going to click the Select All, so it will unselect all, and I will choose the three schools, Amherst, Caltech, and Duke. And I'm going to click OK. So now my list only displays those three. First, I'm going to copy the headers, paste it into cell Q1, and notice the pop-up box that appears. I can use the paste special to keep my source column widths. The next thing I'm going to do is I'm going to copy the data for Amherst. I'm going to click cell Q2, and I'm going to click the down arrow under paste. I'm not going to click paste. I'm going to click the down arrow, and I'm going to go into paste values, and I'm going to use the first one, just paste values. So once again, what it does is it turns these formulas into a number. Now I'm going to do the same thing for Caltech. I'm going to copy Caltech, click cell Q3, paste, and paste values, and the same thing for Duke. The reason why I can't select all three at the same time is because the list is filtered. So I would have to use a special command called select visible cells. So I'm going to copy Duke, and I'm going to paste that using my paste special, paste values, into cell Q4. It's not necessary, but this list is filtered, so it's a good idea to unfilter it before we continue. So I'm going to hit Escape to get rid of the marquee. I'm going to click the down arrow under School, and I'm just going to click Clear Filter from School. Now I'm going to calculate my Euclidean distances. So to calculate Euclidean distances, we can calculate Euclidean distances between two schools. So we can calculate the Euclidean distance between Amherst and Duke. We can calculate the Euclidean distance Amherst to Caltech. And we can calculate the Euclidean distance Caltech to Duke. So to calculate the Euclidean distance of Amherst to Duke for each one of the numerical values, so for median SAT, acceptance rate, expenditures, top 10% graduation rate, I'm going to take the difference between the two values. I'm going to square the difference between the two values, sum all of those squares of the differences, and then take the square root of the total. I know, that sounds like a mouthful. So what I'm going to do is I'm going to take the square root of, open parentheses, Amherst's median SAT minus Duke's median SAT, square that amount, then add the difference between Amherst's acceptance rate and Duke's acceptance rate, close up those parentheses, square that, then I'm going to add, open parentheses, the difference between Amherst's expenditures and Duke's expenditures, square that amount, add the difference between Amherst and Duke's top 10% high school, square that amount, and then add finally the difference between Amherst and Duke's graduation percentage, square that amount, and then close up the square root of the sum of all of the squares. And we have a Euclidean distance for Amherst to Duke of 1.009. Now let's move on to Amherst and Caltech. So equals SQRT, open the parentheses, difference between Amherst and Caltech's median SAT squared, add the difference between Amherst and Caltech's acceptance rate, square that amount, then we're going to add, open parentheses, the difference between the expenditures per student, square that amount, add the difference between the top 10 high school, square that amount, and then finally the difference between the graduation percentages. Square that amount, and then close up the square root. And finally, to do the same thing between Caltech and Duke, equals SQRT, open parentheses, take the difference between Caltech and Duke's median SAT, square that amount, then add, open parentheses, the difference between the acceptance rates, close parentheses and square that amount, then add the difference between the expenditures per student, square that amount, add the differences between the top 10 high school, square that amount, and then add the difference between the graduation percentage, square that amount, and close up the square root. Now we can use data validation and VLOOKUP to create a neat little application to calculate the Euclidean distance between any two of the schools. So what I'm going to do is I'm going to copy the headers, and I'm going to paste it into cell Q12. And what I'm going to do is I'm going to use data validation in cells Q13 and Q14 so someone can choose the school that they want in each one of those rows. So in cell Q13, I'm going to click Data, and then within the Data Tools, I'm going to click Data Validation. Under the Data Validation, I'm going to allow a list, and the source of that list is going to be the schools in my column I. So I'm going to select I4 all the way down to I52. And I'm going to click OK. So I can choose Amherst just to have that cell not be empty. Now I'm going to do it for the second school. So I'm going to click Q14, click Data Validation, allow a list, click in the source, scroll back to column I, make sure I'm at the top of the list, and select I4, all the way down to I52, and click OK. Now, given those schools, I'm going to use a VLOOKUP to look up the median SAT, acceptance rate, expenditures per student. I really don't need the type. So for the second school, for right now, I'm just going to choose Caltech. So I'll calculate the distance between Amherst and Caltech. So before I start, I'm going to go to my original list and note that the school is in column 1, type is in column 2, median SAT is in the 3rd column, acceptance 4th, expenditures per student 5th, 6th, and 7th column. So to make my life easier with the VLOOKUP, I'm going to put the column numbers above, 3, 4, and use the fill handle to fill in 5, 6, and 7. Now for the median SAT, I'm going to type equals VLOOKUP, open the parentheses. My lookup value is going to be Q13, but what I'm going to do is I'm going to fix only the Q. So I'm going to hit my F4 until it says $Q13. So my lookup value will always be in column Q, but in the current row. So when I copy that down to the second row, it'll actually look up Caltech. Now I'm going to hit my comma or type my comma. Now I'm going to use my table array. So I'm going to scroll back to my table array, and I'm going to select I4 all the way down to O52. And once I do that, I'm going to scroll back so you can see my formula. And I'm also going to use my F4 to lock that down. So whenever I copy the formula, it will always make sure to reference the exact same table array. Now I'm going to type my comma again. Now it wants the column index number. So in order not to have to edit this over and over again, median SAT is in column 3. So I'm going to click on cell S12. Oh, sorry, that was S11. The number 3, and Notice that is always going to be in row 11. The column will change, but we'll always find that number in row 11, so I'm going to hit my F4 until it says $11. Now finally, the last bit, I'm going to type comma, and I'm going to type false to make sure that I have an exact match. Close up the parentheses, and I have now looked up my median SAT for Amherst, and I can actually see that that's correct. And I'm going to copy my VLOOKUP out to the graduation percentage, and once again we can see that those numbers are actually correct, and then copy those numbers down for Caltech. Now, if you'd like to calculate the Euclidean distance, this time in a couple of steps, the first thing that we can do is we can just square every difference in each column. So in the first step, we can just square the differences. So in column S, I'll type the formula where I take the median SAT for Amherst, subtract the median SAT for Caltech, close up the parentheses, and square that amount, and copy that formula out to the remaining columns. Now to calculate the Euclidean distance, all I have to do is take the square root of the sum of all of those numbers. So to calculate my Euclidean distance, all I'm going to do is take the square root equals SQRT of the sum of all of those squared differences. Close up the sum, close up the square root, and we now have our Euclidean distance between Amherst and Caltech, and notice it matches the other calculation. But now what we can do is we can now change the school to Duke, and we've now calculated the Euclidean distance between Duke and Caltech, and we can copy this paste it, and paste it again. So we can calculate our Euclidean distances between Amherst and Caltech, Amherst and Duke, and Duke and Caltech. So there you have it, calculating normalization and calculating Euclidean distances.